a motor? There's always two things that you have.
What's the section? AC generator?
Yeah, you can actually make it motors versus generators. We'll do the first one, motors versus generators. Always have two things. And the third is the one that you get. Altyd twee goed, jy kry altyd die derde een. If it's a motor, it's the one that we just said, you have a magnetic field. We often refer to this magnetic field as fixed. And that means I had a north and a south. The second thing that you have is conventional current. In other words, in the motor, we needed to have the cells. That was the second thing we needed. And then the third thing we got was motion. And that motion was due to the interaction of two magnetic fields. The first magnetic field was the one that was the fixed magnetic field, and the second magnetic field was the one that we got from the conventional current flowing through a conductor. And we had interaction between that magnetic field, between the one around the conductor, and we ended up with motion. The motion that we ended up with, instead of saying motion, we can think of it as force. And then we just have to be very careful with this force that we get to realize what that force is. This force acted on the conductor. And because the force acted on the conductor, it turns. So we had that whole loop inside there just now, which I spoke about, and the coil started turning. So motortjie beteken magneetveld, stroom, spoeldraai. Skakel die stroom af, spoeldraai nie. Switch it off, coil won't turn. The fan will only work if you switch the current on. It's not going to work any other way. Now the opposite to that is when we work with a generator or a dynamo or an alternator, a generator of a dynamo, does exactly the opposite. A generator says, I start with a magnetic field. So that's very similar. By 'n generator begin jy ook met 'n magneetveld. En dis ook van magnete af. It's also fixed, so dis 'n vaste magneetveld. Die tweede ding waarmee jy begin en hier ruil dit om. In the generator, you have motion. Daar's beweging. Now that motion normally comes from steam blowing onto the fins of the dynamo, or it comes from wind, or it comes from water. Think of a water mill. So jy het een of ander energie nodig om dit te laat beweeg. En dan dit wat jy kry is elektriese stroom. The one which you end up with is electric current. So in a motor, I use a field and current to make motion. In a generator, I use a field and motion to make current. If I think of the hand rules, the rules that I told you just now, or that I gave you and explained to you just now, if I think of the hand rules, then I told you that you will always start with your fingers first. And that's always true. I told you that when you're working with conventional current, you will always work with your right hand, remains true. The second one that you get, you will always use your thumb. Always. And lastly, the one which you get will always be the one which you will get from the palm. In other words, like in Afrikaans, die een wat jy sal klap. Afrikaans werk het lekker, klap en krag. Pas so mooi by mekaar. Now, when I said I get electric current on the left, it meant that I end up with a force on. Just now, when it was the motor, the force was on the conductor, in other words, physically on the piece of wire, so the wire couldn't help it, it moved. But when it is a generator, we end up with a force on the charges. You and I know they're electrons in the conductor. So now the charges feel it. So in a motor, it's literally the piece of wire feels the force and does that. In a generator, the charges inside the conductor feel the force and they actually get pushed forward. It's like a hose pipe pushing the water through the conductor, the same concept. So if I've got that part right, where does it differ when I look at the motor and the generator in terms of a diagram? For both of them, we would have north and south. For both of them, we'd need a coil. But when it is a motor, I need an electric current source because for a motor, it's going to take electric energy and turn it into motion energy. Het gaan elektrische energie wees wat omgeskakel word in bewegingsenergie. But when it's a generator, we start with motion energy, so it's kinetic energy, and it gets turned into electric energy. So for a generator, it will never, ever, ever have cells, it will never have any source of electricity. So what would they end up putting on our generator so that we would know this one's a generator and not a motor? We would expect to see a voltmeter or perhaps a globe or perhaps some other appliance. So ek kan vir jou sê dis 'n haardroër of een of ander iets wat hulle aannoem het. Mag net nie selle wees nie. Right, so that's the difference between the motor and the generator. Let's look at the difference quickly between how do I pick up, I have mentioned it already before, but let's look at it quickly. How do I pick up the difference between a alternating and direct current? Hoe tel ek vinnig op die skets op of hulle praat van wisselstroom en of hulle praat van gelykstroom? So for generators, I'm not allowed to have the current source. In a generator, I may not have cells, I may not have a current source. But I must, for direct current, have a split ring, and for alternating current, have slip rings. For a motor, direct current has a split, alternating has a slip, but because it's a motor, I need to add current in whichever format is necessary. It's very often comes up in an exam question where they will give you two and say, how do you know which one it is? And how would you change it into the other one? The next thing that's very important for us to know is what happens when, or in a question very often, they ask you how you would get your generator to turn faster or to produce more current, whichever way around it might be. The essential factors that you're always working with is for more force. And what can the force be? If it's a motor, force on the conductor. If it's a generator, force on the charges, so current, whichever one it was. If it was a motor, it would mean, how do I get it to turn faster? If it was a generator, the question would mean, how do I increase the potential difference, the potential verskil, and how do I increase the current which is generated? In both cases, it's about the third one, the one that your palm actually ends up doing. So how do I get more of them? First thing that I do is you always increase the magnetic field strength. So maak altyd seker dat jy 'n sterker magneetveld het. Dit kom van die magnete self af. Now there are two ways to do that. Be careful about writing both when they ask you for three different ways. You can only write both if they ask you for more than three ways or if they ask you for two ways related to the magnetic field. So don't give two things about the magnetic field if you can prevent it. But how do I increase that? Two ways. Ek gebruik sterker magnete. Or secondly, put the magnets closer to each other. The minute the magnets are closer to each other, the magnetic field strength is stronger. The other one, which is generic, which also goes for a motor and a generator, is to always increase the number of turns on the coil. Nou die aantal windings, die Afrikaanse woord, die windings, instead of turns, op die spoel toeneem. Verhoog die aantal windings op die spoel. In other words, you don't just have one loop. My little loop that I draw is just one. There would be zillions of them. And now we get to the next one, and now it's going to differ. If I'm looking at a motor, I would increase the current, sit groter stroom in. In other words, use stronger cells, increase the current, just for the motor. Yep.
Those points, are those just related to the generator?
No, they're for both. So they're for both, and now I'm going to split for the two. So the increase in magnetic field strength and the number of turns is generic for both motors and generators. But now for the motor, increase the current strength. And for the generator, increase the turning speed. And that's going to make the difference to give you, with your generator, more force. And the more force with the generator would be, how do I get more potential difference? How do I get more current? So when Eskom wants to make current for us, they've got to use very, very strong magnetic fields. They've got to have lots of turns on their coils, and they have to turn it fast. Whereas if I want the fan to turn fast, then on a fan, I would increase the magnetic field strength, increase the number of turns. Now that would happen in the factory, but you and I can't do that. So the one that you and I would play around with on a fan or on a hairdryer or anything else that turns is we actually play with this one. We increase the current. Because the dial on the fan or the dial on even a car's wipers, die kar se ruitveers, on all of them we're increasing the current because the dial that we're turning is a rheostat. So we're adjusting the amount of resistance in the circuit. The more resistance, the less the current, the slower it moves. So what are we doing in a car if it's raining hard? We put the wipers so they turn fast. So if I'm turning them fast, I want them to turn fast, it means I must give that part of the circuit more current. So the dial which you and I turn brings the resistance down so that more current flows to the wipers. And as more current flows through the wipers, the motor will turn faster.